Yeah, what's up, guys? So today we're gonna be. Can you see my screen? One second. Uh, okay. Yo, what's up, boys? You guys can. Today, we'll be basically building an Euler estimator from scratch. So before this we did k-means clustering, but now we're doing Euler estimation. So just to go over what sort of we're building is, we'll be building first a single variable and then multivariable Euler estimator. Um. Uh. Yeah, so I think we can just start coding. So let's first create a class called Euler Estimator. Uh, let's first create a class called Euler Estimator. And then let's just basically initialize it with the derivative. Uh, and let's just create a quick init initiation. So this is how we initialize a class. So we initialize it with the derivative, as well as the wait, we initialize it with the derivative basically. And then and then let's just basically say that self.derivative was derivative, so it stores this value so we can reference it along whatever function we want. And then basically we just have to implement a couple things. This derivative will be a function. So so now we need to just do quick def eval derivative. So we're assuming that derivative here is a function. So basically what it does is it does self.derivative of let's say we pass it a parameter x. So let's just say self.derivative.x. So we'd return the derivative at the point okay, so now let's just do some quick testing. So let's just create a def derivative. Let's just basically our function that basically it takes in at any point t the derivative is equal to t plus 1. Return t plus 1. And this makes sense that if you plug in t, the derivative is t plus 1. You can probably extrapolate from that, see the function is probably t squared over t plus t. T squared over t plus t. That's probably the plus c, some constant, whatever constant that is. Okay, so now we're just gonna create basically saying Euler. This is for just basic debug purposes. We're gonna first just initialize it with derivative equals derivative, and then what we're gonna do is we're gonna say Euler dot eval derivative at our initial point. So let's just say, and then let's change a couple things. But instead of this, let's say this is going to be the board. So it passes in an initial point. So we just do x comma y is equals to board. Oops. Yeah, cool. There we go. So we have the x comma y, and it returns point. And then it will return this value. So just to print it, let's just say d1 is equal to, and then let's just do a quick print d1. Right, so let's just check if this just sort of works with the way we've referenced functions. Okay, yeah, it returns 2, we're plugging in 1, so yeah, it makes sense. It's reasonable. Next, we're gonna first start building up the actual Euler estimator. So if we initialize step size, so now we need to do Euler.estimate points. Estimate points, right? And then what we'll do is we'll basically just say right now we'll pass it out. Basically, what we need to do is we need a couple of things to estimate points. We need, first of all, an initial point to start from. And we're obviously using snake case for everything here. Initial point, we need a step size, right? And then a num steps. So okay, so that makes sense. So we start from an initial point where we're doing a certain amount of steps, and we're doing a certain amount of those steps. And what it should return is okay. So what we wanted to return is the starting point, the point after the first step, the point after the second step, the point after the third step, and the point after the fourth step, right? So now let's create a. What we can do is we can create an array, and let's call that points, right? So these are all the points we go through. So first of all, point dot append initial point. Points dot append, and then we do so for I in range num steps, right? What we need to do is we need to basically um uh we need to basically in the range of num steps, we need to calculate next point. Next point is equal to current point. Okay, this is gonna be at the end. So current point is gonna be initialized as initial point, right? So the first point is the current point, right? So the next point is actually this should be the other way around. Okay, so the next point, right? Is equal to a couple things, right? So so let's calculate the next x is equal to initial point. Oh, okay, so current x, current y, we should probably just track that, like x point dot 0, current y. Okay, so next x, and then we need a next y. Once we calculate this, next point is relatively simple. So, the next x will be the initial point, or next x will equal next x, current x, plus step size. And then next y will equal, what? So current y, plus the derivative times the step size. So the derivative, so we're doing, and then the next point is just going to be next x comma next x, next y. So now we just do points dot append next x comma next y. That way we have easy access to it in the future. And then what we need to do is we just need to basically just reset all the things. So we need to say current x is equal to next x. Current y is equal to next y. And then, and the third point is that the current point is going to be equal to the next point. So then at the end of once we do this, we need to return points. And let's just do the example they did over here. So in the example they did, they said instead of return t plus 1, they did the exact same example. And then let's check out Euler.estimate points. Let's just do that. This is like basically equivalent to running a test, basically. Okay. This is because theirs in the Python console, ours in actual code. Okay, let's run this. Oh yeah, if anyone wants to see this code, it's available on GitHub. So let's check the result. It should be 1, 4, 1.5, 6. Wait, what? 2, 8.5, 3, 5. Okay, no. So the x values are right, but the y values are just wrong. Let's try to figure out why. Our derivative should be the same. Well, it's 1, 4, right? And then it's plugging in the 1.5. So the derivative should be 3.5. 3.5 times 0.5. 3.5 over 2, 7 over 2, 7 over 4. 7 over 4 is about 1.75. 1.75 plus 4 should be 5.75. Oh no. Okay, yeah, that's what it should be, but ours isn't. So there's. Oops. Didn't mean to just delete all the code we've written. There is an error, but where's the error, right? Well, even from the first point, there's an error. So maybe there's an error in the way we're calculating. Ooh, dang it, bro. This is where the error is. We forgot to multiply by step size. As you guys know, Euler's method, like, there has to be step size involved. Let's check. Yep, and we've debugged it ourselves, finally, and actually written some working code. Okay, cool. So let's just do, so uv pip install matplotlib. You know what? It's probably fine. Let's just import matplotlib. And basically we need import matplotlib, and then from matplot. Oops, didn't mean to do that. Control C. exit. Okay. And then do from matplotlib. We need to import the pyplot as PLT. Pyplot as PLT. Okay, cool. So now we're here, right? We have the output, let's say, and then we just need to do yeah. We forgot. Now we need to just basically for one curve. Uh, so it's telling us. Oh, you guys can see this part of my screen. Um, 1 second, boys. Let me just. Yeah, there you go. You guys can just quickly see my see that. Dude. I don't know if you guys can see it. It's kind of hard to see, but anyway, you guys can see here. It wants us to do it for dy over dx equals x minus 2. Uh, so let's do that. So let's modify our derivative so it becomes t minus 2. Right? It takes the input minus 2. And for one curve, use the initial condition y equals negative 2. Okay, so this output is all that we need. But the initial point is y equals 0, x equals 0, y equals negative 2, right? So boom, bang. So the step size should be and then now that we have this output, we can do x equals bam, y equals bam, and then we just do for x for k comma v in item uh, I'm tempted to um ooh, a nice thing we don't have to do. So what we can do is we can actually just do this. So we can say that points is equal to zip uh, output, and then we can just say that x comma y equals points, and then we can do plt dot plot. So we need to see x comma. Let's just do x comma y, and then plt dot show. And then we actually need to do something else. So plt dot use qt5ag. I should probably fix some of the errors that we have. Let's see. What's the function exactly? I'll just look it up real quick. And actually it's supposed to be matplotlib here. Let's just do a quick uv pip install pyqt. Bro, I'm struggling here. Okay, uv pip install pyqt. Why is this not right? Oh, okay, we good. We need to do UV pip install PyQt5. Oops. I forgot we have to do PyQt5. Okay, it's fine. It is what it is. Okay, let's see how many, it's, ooh, okay, let's see, we're almost halfway there. Downloading the packages we need. Feels like such a hacker man. Okay, so let's just run it. Okay, so y of 0. We're doing from 0 to 5, right? So if that generates 2, we need to double that and add 1, so let's do 10. Yep, this looks about right, because if we look at the thing is, if we do, that would be a parabola, which would be x squared over 2, minus 2x. X squared over 2 minus 2x would be the parabola. So we factor that, that becomes, x over 2 minus 2, so that would be x equals, yeah, I don't know, x. This works, and obviously the slope is 0 at 2, so that should look right. That looks right. But to be honest, though, to derive the formula of that would be dy by dx equals thing, integrate both sides. It would become x squared over 2 minus 2x plus c. And now we know c is equal to, we'll find c anyway. C is equal to negative 2, so it's x squared, minus 2x minus 2. I don't know. Yeah, it sounds right. Yeah, it looks right. It looks right, at least intuitively. It should be pretty good. Okay, cool. Then use another curve with y of 0 equals 0. Oh, all 5 of these curves can go on the same plot. Dude, I'm gonna be honest, we good. We're good. We're good, bro. We're chilling. Okay, good. Yep, it looks right. Okay, now we're gonna do a multivariable estimator. So let's just add another file called multivariable estimator. So this is where if there's multiple variables, but how do we? I don't think we can really plot this. Consider the following system. Yeah, you guys can see my screen anyway. Consider the following system, right? And we're trying to Euler Estimator. Okay. Yeah. So what are we actually taking steps in though? That's what I don't understand. Oh, T. Okay. Yeah, I understand it. It's doable. But I think I'm gonna head off for today. I think I'm just gonna chill for a bit.